Now we discuss the momentum and explosive forces during the explosion. Total momentum will be conserved. So here we can write initial momentum is equal to final momentum. Here we take the example we take is gun and bullet. First we discuss the before firing. Before the firing, velocity is 0, so momentum is 0. So here we write initially when gun is not fired, the gun as well as the bullet is at rest position. So total momentum is 0 before firing. Here we discuss the case when before firing total momentum before firing is 0. Now we discuss the after firing. After firing, the bullet that is mass and move with velocity v, and the gun that is mass is capital and move with velocity capital V. So here we write the velocity of bullet is V and that of gun is capital V. Now we can write as by the law of conservation of momentum. Total momentum before firing is equal to total momentum after firing. So total momentum before firing is equal to 0. Total momentum after firing is mv plus mv is momentum of the bullet and capital M and capital V is the momentum of the gun. So it can be written as mv is equal to mv. Here with the minus sign, capital V. So this is the recoil velocity of the gun. This expression is the recoil velocity of gun. The negative sign shows that the recoil of gun is opposite to the velocity of the bullet. Now we discuss the explosion of the explosive material. Here we take the example of the exploding bomb. Here is the bomb before explosion. This is bomb before the explosion. Initial momentum is 0. Now we discuss the after explosion. After explosion, each move with different velocity but in opposite direction. These are scattered pieces of bomb after explosion. So here we write scattered pieces will travel in positive and negative directions when the velocities of all the pieces added together. The resultant velocity is 0. So momentum before and after collision is 0. So here is the momentum of the final is also 0 of the scattered pieces.